Hello, I am Rushabh Shah, a second year student pursuing my Masters in Construction Engineering and Management at SET University. Welcome to my third semester studio portfolio dedicated to integrated construction and practices, where we studied the construction of a high rise mixed use project under the guidance of my tutors, Dr. Jyoti Trivedi, Dr. Bhargav Dave, Professor Paramjit Lota, and Professor Sanjana Meghwani, along with teaching associates Isha Patni and Urva Patel. The project is mixed-use project having square feet base contract and its estimated cost is 350 crore approximately. The structure has three-level basement, ground floor and first floor for commercial spaces, followed by residential floor from the second floor to 17th floor. It has a total built-up area is 5 lakh square feet. The scope of work we have taken under the term of our studio for modeling is 3 basement, 2 floor commercial and 1 typical floor. And for the LPS for construction activity tracking, so for that our scope of work is 15, 16 and 17th floor. The current stage of project is on 16th floor. It is situated in satellite Ahmedabad. The primary stakeholder includes the client, third-party consultant like architect, structural, MEPF consultant, and the contractor. Within our studio roles are allocated among my three group members, and I serve as BIM coordinator and fire and plumbing consultant, with specific roles and responsibility outlined here on as shown in slide. So, as a BIM coordinator, after preparing the LOD 300 model in Revit by different consultant, I conduct an interference check and its process is shown in the slide. After receiving the report, I identify classes in architectural, structural and MEPF, especially in architectural and structural discipline. The classes identified are the stair cast in place. So stair top exit cannot reach the top elevation of the stair. So for this we also give the suggestions to the assigned person is architect, and the second class is a basic brick wall overlap. So we also give the suggestion for this also. So in structural discipline the classes are the beam is slightly off axis. This class is done by structural consultant and this is the modeling error. And the other class is highlighted diaphragm wall overlap with footing. So this is also a modeling error. So this is assigned to the structural consultant and he has to resolve the error, and also we have attached the report showing the same class ID for the interference check. This 3D site layout gives a clear and detailed view of the entire site. It shows how different areas are arranged where the infrastructure is placed. This visual helps everyone involved in the project understand the site's design better, making planning and decision making easier. So we have shown some components of the site. This is reinforcement details, the glass door, the material storage and contractor office are shown here. After conducting interference check in Revit, our next assignment is clash detection in Navisworks. We tested clashes between interdisciplinary and intradisciplinary. So we also shown the interdisciplinary and interdisciplinary class on the slides. Other than this, we also done the classes between architectural versus MEPF models and structural versus MEPF models. We set the tolerance at 0.010 meter. There are three types of class: hard class, soft class, and 4D workflow class. Here is where the model also displayed. So this model is structural model showing the three basement, two commercial floors, and one typical floors. Other than this, we also shown the plumbing models images. So this is done by us only. This is the pipe connection with fixtures and pipe connection with flow drain. These are the different pipes given with different colors. So coming to intra-model class detection. We have shown classes between architecture versus architecture with a tolerance set 0.010 meter as mentioned earlier. We identify 65 classes. After reviewing them, we categorize them into major and minor classes. Minor classes can often be resolved on-site due to modeling errors. Here we describe the classes and provide suggestions for the resolution. So total classes is 65. From that we resolve by creating sets and doing changes in our architectural model. So we resolve 61 classes. So the active classes are only 4 classes are active currently. After proceeding to intermodal class detection, we display classes between architecture versus structure. The tolerance limit remains same as previously set, and we identified 65 classes. From that, only 2 classes remain active after applying rules and resolving some classes in Revit. These 2 active classes are shown in the slide. Moving to class with other disciplines such as structure versus firefighting. The consultant did not provide sleeves drawing. Consequently, the contractor installed the sleeves independently, resulting in misalignment and requiring rework. So we suggest the MEPF consultant and structural consultant coordinating among the consultants. So they use ICP approach. So structural consultant and MEPF consultant review their models. After that, they also give the suggestions and give the sleeve drawing. So it will reduction in time, in cost, and also in rework. Moving on to the next assignment, the last planner system has significantly aided us in understanding commitments, reason for variance, early identification of constraints, and applying learning for improved PPC and continuous enhancement. We have prepared the MSP schedule for the current construction activity of the 15th, 16th, and 17th floor. These activities are divided into weekly tasks which we track on site to better understand and appreciate their benefits. The image on the right side was taken at the site itself. Upon completion of each activity, a representative from the contractor marks it with a single line on the chart. Then a client-side engineer verifies the activity before marking it with another line. These tables show the planned activities and the actual completed activities along with the PPC completion of each week. Coming to the graphs, the first graph indicates that week 1 had major activities as server were rescheduled in week 2. There is delay due to strike by course aggregate supplier. Week 5 had no activities due to the Diwali break, leading to labor shortage in week 6 as a result of the holiday. The graph shows an average PPC of 74% over the 6-week period. Week 1 achieved a high PPC of 100% due to minimal constraints, while week 6 had the lowest PPC at 29%, primarily due to labor shortage following the Diwali break. The graph indicates that the primary constraint was labor shortage, which caused delay in the successor activities. Additionally, a material strike affected the concreting phase, but this issue was managed by paying a higher rate for concrete during the project period. Coming to the conclusion, in clash detection and interference check, we clash detection based on the specific tolerance value helps the identify interference between components from various model disciplines such as architectural, structural, and plumbing. We have successfully conducted clash detection to ensure that these elements are properly coordinated and conflicts are addressed before construction begins. The next conclusion for LPS. The last planner system improve understanding of commitment, identified reason of variance, and inbuilt early detection of constraint, and apply learning to enhance percentage plan complete and drive continuously improvement. Thank you.